What about ye? The build Sandy Anderson and I were having a chat on the blower the other day about piezo injectors in a diesel, and just happens I have a 1.6 diesel common rail Volkswagen in at the minute, and we'll do a wee bit of testing, a wee bit of mucking about, see how these things work.
A little Volkswagen Caddy 1.6 TDI common rail. So you can see it's got a misfire. And I said in the first bit of the video this was a solenoid type. It is not. It's a piezo injector. So we went up to Volkswagen and we got a new injector. £400 plus VAT. Roddy says there was never a doubt. We're at a Renault Scenic 3 2013 1.5 DCI. It will be the injector. Oh, look at that. So at Renault it works out £155 plus VAT for that injector. So we're back again at the Renault Scenic. We had a cylinder 4 misfire. So we got a new injector, put it in, coded it in, and after I done that and he tried to restart it, it would not start. So we went and got the injectors tested, and indeed the other 3 failed. So we've now got 4 new injectors on the thing and it still will not start. You'll never guess what's wrong with this car. There's ball bearings in the fuel rail. Ball bearings, oh no. Right. Well, there you go, she lives again.
So this car here runs fine. It's not in for an injector problem. So what I've done is I've stripped back one of them here that I can get access to. It's handy, and we'll do a bit of scoping. So a piezo crystal. There, we all know that if you press these, it produces a voltage, but if you pass current through them, it does the exact opposite. It expands. So in the top of these there's a what they call a piezo stack. There's a lot of these all together, and the ECM puts a voltage across it and a current through it to make it move to act on the injector. Another way you could think of it, maybe it's a bit like an LED. So if you pass current through an LED, it lights up. But similarly, if you put light into the LED, it generates a voltage. So that's then what a solar cell is. I have a couple of wires split from the protection tape there, and it's just to open them up. And what we're going to do is we're going to measure current, but we're going to measure current with this 2000 amp clamp from Piezo. So Piezo, this is for a 4425A, and it has the BNC plus connections on it. And the selling point of this is you don't need any batteries in it. So the power for this is supplied from the scope itself. However, this is also advantageous. It's quite slim there at the top, and it does have a big hole, but it's auto ranging. This thing will measure low current as well as high currents, so it's quite versatile. This, so it doesn't really matter which wire you go onto here because current's passing through it. So we'll pop that around that brown one there, and we'll maybe get a voltage probe in that wire as well. So let me see, we'll ground that, and we'll just back probe into that brown wire. So it doesn't matter what wire you do this phone. Let me see. Are we in? That's us now. Right, so okay, that'll get us started. Okay, so we're going to use Piezo 7 for this, and there's a wee bit of information on this which is going to just tell us a few things. Perhaps so in that there we have injector diesel, common rail diesel Bosch piezo injector. Now this is a Siemens system, but it's very similar. And there's a wee guide in here, so we'll load that up. And we quick read through that. So yeah, basically just says just do a current test, and we're expecting something like that there. And yeah, there we go. So a wee bit of information. Let me see. One or more pairs of positive and negative pulses, which respectively drive the opening and closing of the injector. The pulses have peak amplitudes plus or minus 7 amps and cycle from 0 amps to their peak value within 100 to 200 microseconds. The precise values may vary. Okay, when the accelerator pedal is depressed and there's demand for increased engine torque, the main injection duration increases. So we'll see if we can see that. With the engine at higher speed, all events occur within a shorter total time period, and their peak currents increase with increased alternator output. All right, so the voltage just goes up. So there's a couple of examples there with the red being voltage. So we'll maybe see that because we're measuring voltage here. So a wee bit of more information. Piezoelectric diesel injector delivers atomized fuel directly in the chamber when signaled to do so by the ECM. Pilot injection, post injection. Piezo crystal structure is compressed. It produces a voltage. Conversely, when a voltage is applied, the crystal expands. So that's what we just talked about earlier. The piezoelectric injector uses these characteristics, applying a voltage across a stack of several hundred wafer-thin crystals. The result is a linear change in stack height, which causes a movement in the attached needle. And once the crystal structure is changed, the electric current does not need to be maintained. The stack will hold its state until an electrical current is applied in the opposite direction. So I think that's the important part here. So you apply a current to open it, and then you apply another current in the opposite direction to close it. So there's a wee view there of that. So in around here on that wee drawing there, so we can see the polarity is one way to close the stack, and the polarity is the other way to open the stack. It's for the opening and the closing of the injectors. So we'll see if we can see that. And this thing will give us a sample waveform as well, and we'll start the car. It just made the screen a wee bit brighter there, so you maybe hopefully see it a wee bit better. I have to press the clutch to start this vehicle. That's us. See what we've got. So we'll run that. That's something similar. And you can see, we'll bring that down a wee bit. So that's with a 2000 amp clamp. And what I might do is put a wee bit of filter in it. Oh, wrong way. Bring that up a wee bit. Okay. Get rid of that. Wait a second. So what have I got? We have about 4 amps in this one. And we'll bring in our voltage. And we can see our voltage is 116 volts. So what's happening here, this is not like a petrol injector where you would get 100 and odd volts from an inductive kick from the winding inside the injector. What's happening here is there's a capacitor in the ECM, and it's charging it up, and it discharges the capacitor and produces that 120 volts. So the large voltage here is coming from the ECM. It is not an inductive kick from what you would see in a petrol injector. So it's a different animal entirely. So we'll just raise that up a wee bit. Well, let me raise that down a wee bit. Bring that down a wee bit. So you can see it better. Yeah, we're about 120 volts there. And yeah, let's bring that in then again. Yeah, it's about 4.2 amps. So, let me see. So, what we want to look at is we want to see this changing. So whenever the injector opens a wee bit more and delivers more fuel. So we'll just give it a wee bit of a blip here and see. Give the throttle a bit of a blip. Let me see now. Okay. Right, we just knocked the car off there, so you can maybe hear me a bit better. We've stopped our capture, and we'll just go through a few of these frames here and see. Right, so there's a wider voltage there. So the voltage is turning on, goes up to the 120 volts. It's a bit wider because I was revving it, and we can see that's reflected down in the current waveform. So the current is positive here, and this time here then is that the amount of the injection pulse, as it were. So if we bring a couple of rulers in just to see in a wee second if all this lines up. So we can see the voltage starting to progress vertically upwards, and it's held, and then the voltage then goes down the way, and the current goes negative. But this time here is clearly wider whenever we're revving it compared to when the car was just idling, you know. So let's see. So there's our width, 668.7 microseconds. So that was something like what the guide told us, I think. So there we go. We'll maybe add a few more challenges onto this and see what we can see. Right, the car run again, and just run the scope, and we'll have a few additions. So on channel C there, let me see. We'll have a Piezo pickup on the injector line. On channel D, we'll have, I'll just get rid of these rulers. We've got a pulse sensor in the exhaust. So we'll maybe bring that time base up a wee bit and maybe see us a bit better. No, that's far too much. Hold on. Right, so we're going to add voltage, I think. Yeah, we'll put that. So the gold coloured one is a pulse sensor in the exhaust. So you can see the 4 strokes there, 4 pulses from the exhaust. And what we'll have on the green is a piezo pickup on the actual injector line. I'll just show you that in a minute. So it's picking up the fuel. So you can see it's striking. So let me see. It's going to be better. It's way up. So it's a bit too much there. So yeah, so the green is the actual fuel delivery. So maybe give it an RV wave and watch that green trace. Okay, stop that. We'll just go through frames, and you probably saw it yourself when I was doing that. So there's the revs increasing. You can see the exhaust pulses going mad there, and our green is delivering more fuel. You can see the pulses there. Right, so that's just idling there. So the exhaust pulses, I can see where I've revved it. Yeah, just there. So that's how we piezo pick up there that I have cable tied to the injector fuel pipe there. That's going into that injector that we're also reading the current and the voltage on. And we had the Diagnostics pulse sensor up the exhaust there for that other 4th channel. We'll maybe get something out of that, but just before we finish up, just before we wrap up, I'll just show you a new light that I got and what I was using there to film this. That's it there, it's just stuck on the bonnet. It's a rechargeable job, so I'll just turn it off so you can see it. There we go, that's better. So yeah, it's a couple of magnets on each side of it there, and there's 2 brightnesses, and that bit in the middle swivels with respect to the mounts, and you can get them out either way, so you could just hold it like that if you wanted. So I thought I was good by that. I thought very happy with it. I've only had it a few days, and you charge it up. There's battery in it, so you charge it up. You get an adapter for the mains and also an adapter for you can charge it up with cigarette lighter adapter as well. You get that with it. So that's available in the Amazon store there. It's made by Ring, and that's 40 quid for that. So yeah, quite like the Ring products. So not a sponsor, but it is available in the Amazon shop. Links in the description. Oh, and I forgot to mention, doing that current test there, that's fine for a known good there. But as we saw as Sandy's video right at the start, what happens a lot of times is if it sets a fault code for a particular injector, a circuit code, it will the PCM will disable that 120 volt pulse to that injector, so it won't pulse it anymore if it doesn't like it. So you know, if you have that fault code set, you won't see any current flowing at all. So for that particular injector, so you know, it's one of those sort of tests where you'll only see anything really on a known good because the ECM will just shut it down if it faults most of the time, a lot of times. So okay, so there we go. Maybe get something out of that, and just flicking through these waveforms here. So there's a rev there, and a wee bit of a rev there maybe. Anyway, wee bit more on piezo injectors. These are known goods, so this car's running fine. It's just in for a service. DMF's a wee bit rattly, if you maybe heard it there, but apart from that, we'll get those wires, a bit of the protection tape put back onto it again, put it back the way it was, of course, and hope you got something out of it, and all the best, and bye-bye! Bye-bye! Bye-bye, Poppy!